Hello and welcome. So this is the fourth day of Creative Armenia Week Virtual Summit, bringing together the brightest minds of arts and sciences for in-depth conversation on arts, on science, on the future of art, and where we're going. So in our first day, we had a really interesting conversation called Tigran by Tigran with Tigran Hamasyan and Tzidoktian. Two leading artists now representing and being ambassadors for Armenia around the world. And then we went to a second day, which was a conversation with leading curators in Armenia, who are leading and defining the virtual art scene. And on our third day, we had a really interesting conversation with Howard Kazanjian, who is a Hollywood producer standing behind such films as Star Wars, Raiders of the Lost Ark, was worked with giant filmmakers like Billy Wilder and Alfred Hitchcock. So yeah, and today this is going to be a very interesting and exciting conversation about art and science, the art of science, the science of art. And yeah, I'm really happy to welcome our two panelists today, Dr. Garik Israelian and Aroussiak Gabrielian. Before I introduce you to the panelists, I'm going to ask you to feel free and leave your questions in the Q&A section, which is at the right corner of your interface. So yeah, at the end of our conversation, we're going to take questions from you. So feel free throughout the conversation to leave any thoughts and any questions to Mr. Israelian and Aroussiak that you want to know. So yeah, without further ado, I'm going to introduce you to our panelists, Dr. Garik Israelian, who is a renowned astrophysicist whose works have had immense impact on the global scientific community, an inspiring thinker. He devoted his life to science, publishing more than 250 scientific articles on a wide variety of subjects. In 1999, Dr. Israelian led the team which made an incredible discovery, finding the first observational evidence that supernova explosions are responsible for the formation of stellar mass black holes. But science is far from his only talent. An all-round curious mind, he compiled a unique library of acoustic sound waves produced within the bodies of stars. The research is what inspired Dr. Israelian to join forces with Dr. Brian May, astrophysicist and legendary guitarist of the band Queen, and create STARMUS Festival, uniting incredible minds over their passion of astronomy, space exploration, sciences, music, and art. And yeah, welcome, Dr. Israelian. We're really happy to have you. And also joining us is Dr. Aroussiak Gabrielian, although I know her, so it's a bit, I call her already Aroussiak. So Aroussiak is an environmental designer and bioartist with training in architecture, landscape architecture, and media arts. Aroussiak is also presently an assistant professor at UST Architecture and the co-founder of Foreground Design Agency. Through her creative and scholarly work, she has extensively researched alternative environmental futures and has received recognition for her imaginative and thoughtful speculations. Her work has been acknowledged by numerous prestigious international awards and renowned publications, including Fast Company, CBS, Forbes, and beyond. Aroussiak is also the recipient of the 2021 Creative Armenia AGBU Fellowships. So welcome, Aroussiak. We're really happy to have you both here. So yeah, I'm going to ask a burning question as an opening question, which is about art, culture, and robots. So especially in the post-COVID world, we've seen this drastic rise of NFTs and these non-fungible tokens. We've seen people buying crypto art, and there is this new idea of what an artistic ownership and ownership of artworks really is. And we have virtual influencers, we have virtual singers. We're actually incubating some of such programs at Creative Armenia. And there are also these two groups of people, one that is really embracing this technological shift and looking forward to what's coming next. And there is the other that is really nervous and thinks that the NFTs, doesn't understand the NFTs, and thinks people who are buying the artworks are really bragging about it. That's the only ownership that they have. So I really want to know what's your stand on this. What do you think, where we're going, and do you embrace it? what's your opinion? So yeah, I would like to hear both of you.
Go ahead, Aroussiak.
Sure. Thanks for having us, Anush. Well, I think that the separation that we often put between culture, nature, technology is a false one. Of course, these lines have been blurred and have been blurring for a really long time. And so I think in my work and in the work that I am inspired by, there's a really fluid kind of fluidity and porosity between the sphere of the natural world, the kind of human in terms of agency, and the kind of machinic. And it's acknowledging that each of these entities have agency in the design process, and that you are essentially, as the human in between these, collaborating with these systems, be it biological systems or biological organisms, or I guess in Dr. Israelian's case, it could be even cosmic forces, as well as the kind of machinic. And so I don't see a separation. And so I embrace both the kind of technological and the natural, and try to, in my work at least, try to navigate and mediate these two forces.
All right. Well, the separation, I think there is still some separation. They're not exactly the same. The goals are different. Historically, arts were created to express human emotions, right? So that was the first. So based on human feelings, people were scared. They were very impressed. They have to paint. They have to write. They have to create music. So it was basically coming from natural, from human emotions. Science was coming from a different part. It was coming from when we were trying to understand nature. We're trying to understand and trying to explain nature. So that's how the science started. And obviously, when we try to interpret and understand nature, we also have emotions during this process because it's an emotional process. Understanding nature is quite emotional. So it's not surprising that people who were trying to understand nature were creating laws and even maths and everything. They were quite emotional people. They were going into music. They were inspired by stars. They were inspired by everything they see and they try to interpret, and were creating arts, just trying to bring this research, these discoveries and everything into paper, into music even. Johannes Kepler and lots of scientists were also musicians. So basically, these guys were they were trying to bring those emotions and this energy coming from research, from science, from nature to very simple human emotions. So there is a link, there's a bridge, but the goals are totally different, because when you go to exact science, and if I consider just a classical scientist, what they do, they go work, they go to office, they do their research, they come home, and there is no single component of science. It's very tough programming, lab work and so on. There's nothing about science. So probably 99.9% of scientists live a life like that.
Yeah, I remember you calling it routine science, right?
It's a routine science, and 99% of scientists live with this. It's probably a bit different with artists, but that's an interesting question. So we can go ahead and analyze this. But yes, this is what I think about. Yeah,
I think there is this. There is also the misconception of what artists are like. Like they're very isolated and very messy. They're creating outside of the box and not very routine people. But yeah, I think in both spheres there are like misconceptions that are now, being being explored and also found untruthful. So My next question is mostly to Mr. Israelian, because I know that before, way before you were a scientist or studying science, your first job was in the theater. You
Yeah.
hand in the theater. So can you tell us more about that and how that has carved the person and the scientist that we know now? Has it been like a definitive experience for you? Can you tell us more about that?
No, not really. I mean, I was working in a theater because I couldn't immediately get to university. So my knowledge of maths and physics was so basic, so was not sufficient for studying at the university. So first I went to work in a theater because I didn't know what to do. I had to do something. So my first choice was go to work, and what just a theater was no reason to go to work in a theater.
Yeah.
But then it was sci-fi which brought me to science, and it was just by chance from sci-fi movies, then sci-fi books, and so on. But nothing to do with the theater. In fact, it was so boring because when I was reading sci-fi and so on, and I was going to work and watching these acts of students in a theater, those, and I was saying, this is so boring. This, I mean, how they can do this silly, and it was very simple, a simple act, about whatever, right? So I was watching this and said, Jesus, how you can dedicate your life to this? I mean, so, so it was even more convincing for me that I have to go into something super creative, very interesting. It has to be something which no one understands. There's a really high science, astronomy and stars, and so in a way it helped me even to choose my profession, because I was more convinced that this is not for me. I'm not going to do anything. So not, although music was different, I loved music, I was always with music playing and so on, but at that stage the music which I was following in late 70s was nothing to do with science. It was really heavy rock music and even classical music, but there's a separate world. So
Yeah.
just always separating the musical world from the world of science and sci-fi, until we went to more progressive electronic music with Pink Floyd and Jean-Michel Jarre, and then I could see really they merge the music which is inspiring by it makes you to think about stars and the universe and so on. Then I said, okay, yeah, there is something then that's very interesting, and electronic music and so on, and that's
Yeah.
when I could see really the the two, science and art and music, getting together, and so more. But before that, with classical music or rock music, so it was really totally separate things.
Mhm. Yeah, well, that has been a really exciting and long journey. So,
Yeah,
yeah. So I wanted to, as you were talking, I understood what the story, like the idea of a story is really important, even though the theater didn't really inspire that, but the sci-fi and the books and the films really inspired to explore the stories and to understand the world in stories. So yeah, and recently actually, while I heard, I learned this phenomenon from Chris Hadfield about the Hohmann transfer orbit phenomena, and yeah, he was talking about that, and then he mentioned that how he discovered it was actually based on the book that he was reading. It was a German science fiction book, Kurt, I think Laswitz. And based on that, he really made that discovery of the orbiting system. And yeah, that really sparked this idea of how actually science fiction can inspire the actual science. And so I wanted, yeah, to know, is there anything in your work, either in Aroussiak's work or in Mr. Israelian's work, that has been inspired by books, by stories, and really either predicted or, yeah, opened a new question that then became a reality, a new truth found, or anything?
Absolutely. In my world, I'm constantly cultivating my kind of artistic ideas by surveying lots of literature, from fiction to actually scientific writing. So Lynn Margulies's Symbiotic Planet is one example. She's a biologist who, for the first time, had a really groundbreaking work that the whole world is kind of driven by symbiosis, that evolution actually is a result of symbiotic relationships, as opposed to the kind of, dominance of the strongest entity in a system. So these ideas from science, from fiction, and from theory as well, theoretical and kind of theoretical scholarship that's criticizing often or making visible the power dynamics within the natural world and the kind of structures that we're all embedded in. These are constantly pulling me into ways in which I could, I'm almost playing with these ideas as a designer when I work. I try to respond to these pieces through my works or be in conversation and dialogue with them. So there's a very, very close link in my work to written works for sure. And I see this also just everywhere, in terms of the power that it has to inform certainly the arts.
Yeah.
Yeah, I think in my case, certainly there was from sci-fi books. When I was young, I was very impressed by Arthur C. Clarke's book called Encounters with Rama.
Was it part of the Foundation series?
No. There was a different 3 series about Rama. It was called Encounters with Rama, and the Rama Returns.
Yeah.
3 books. Amazing. I love the books. And then, so somehow it brought me to the idea of how we can change the sun, how humanity, or how a super civilization can be through pollution. So imagine we use the sun, the solar atmosphere as a garbage can. So everything that we produce, we throw it on solar atmosphere, which is quite possible because that's what is going to happen next 100 or 200 years with all nuclear waste. Because we are going to produce a lot for lunar base on Mars and so on. So what we are going to do with this? We cannot keep them on planet. So the best way is to just throw them to the solar atmosphere. But and it's safe actually, nothing is going to happen with the sun because these heavy elements are going to sink. They will virtually end up in the core of the sun, they will be fused, blah, blah, blah. So nothing is going to happen. So it's the safest place. But apparently when you send them to the sun, they will stay in the solar atmosphere for many thousands of years, maybe 1,000 or 2,000 years. So during that period of time, so aliens can detect in the solar atmosphere overabundance, a huge amount of nuclear waste. So that will be a clear signature, very nice signal that there is something going wrong with this. So someone is polluting the sun. Cannot be natural, right? It's So I was quite inspired by these books, and I was reading, and then and I started to do my own research project on looking at the very interesting signals related to composition of certain chemical elements and species and so on, and what we can do in stars that have planetary systems. And now because there are thousands of stars, and then you need special techniques and so on, there are many interesting things. So certainly, I mean, it came from sci-fi, and I'm really doing a project now just dedicated to these very specific research, or searching for signatures and signals in the atmospheres of stars which have planetary systems. We don't know if there is life or not. That's a different question, right? But at least we have means, we have technology, and we have models now. We have enough knowledge. We just have enough knowledge to go and do this kind of research. So I spent last 5 or 6 years been dedicated to this project. It can take another 10 years or so. I don't know, but it comes from sci-fi.
Yeah. So there is, I think, like there is there is the imaginary, the visionary part of it, and then we just without any responsibility we imagine it, and then there comes the real work to make it into something real. So Aroussiak, you mentioned the symbiosis, and I think That's a very pivotal part of your work. I know that you very bravely call yourself a futurist, a futurist designer. Yeah, and I think that very well explains the work that you do. So I wanted us to talk about a little about the Posthuman Inhabitants project that you did, because it's a really exciting one. Yeah, just to give our audience an understanding, we're going to play some images from it. So yeah, this is your Posthuman Habitats project, through which you created a wearable landscape system. It's a clock that, and you've really gone into the nuts and bolts of it, really designing it to be wearable and to provide sustenance for the wearer, and also to, to attract insects and other animals to it. And also the garment promotes a healthful diet, lifestyle, and gardens that are fed, nourished with bodily waste. So there is the whole, a new reality for us to embrace. As a futurist, and I wanted, to know how you think this is. This more like an artistic project for you, or if you're envisioning and really defining what the future should be like?
Well, that's a great question. So the project actually emerged, well, it has kind of two starting points. The initial one was I came up with the project after the birth of my daughter, and I was kind of observing my own body that was doing very strange things, producing the exact nutrients that this being required, and delivery system that was very efficient. So I was amazed and astounded by this very efficient system. And I started to think, well, could we, to go back to the symbiosis, could we design something that could be equally nourishing to species beyond the human? And so essentially this acts as a second skin, almost, this cloak, where, and the second starting point of this was that in the future, to go back to the futurist thing, if we go forward in the same processes, in the same wasteful kind of systems of industrial agriculture that has diminished the microbial life within soils, if we continue along this path, soon our soils are not going to be able to support life, and they're not going to be able to support our food that we grow. So the kind of timing, the temporal range of the project is in the future where there is no soil to grow our food. How will we sustain life? And so this brings the system on our bodies, and it taps into the human system and uses waste as a kind of nourishing system, because actually, it's funny, because the thing that weirds people out most about this project is that it's actually filtering urine and using it as irrigation. But there is so many research groups now that are actually finding that this functions so beautifully as a fertilizer. There's a group in Vermont called the Rich Earth Institute. That's an NSF-funded institute that's looking specifically at reclaiming urine as a fertilizing source for agriculture. And so there's kind of connections to actual scientific work being done in these various different areas. But it's really, it was meant to be speculative, although bits and pieces of it we're seeing now kind of manifest in the world. There's all this interest in hydroponics also, which is the growing of vegetables or food or plants without soil, with just a drip kind of nourishing liquid. So the project itself uses cloth, felt, that these vegetables and foods and fruits and some legumes and nuts are directly seeded on. And it functioned, the prototype functioned. It was able to produce about 20 pounds of crop. And so it's I don't know, it's the kind of future world, again, that it's trying to respond to is this possibility that we might not be able to sustain ourselves, and whether or not we can be more symbiotic and more collaborative and co-evolve with these insects and microbial life that bring that grow our food, that help us grow our food.
Yeah, that's really interesting. So the prototype is now like flourishing both literally and figuratively. So what's going to be the next step? Are you going to, like, this is the prototype, so you're going to then be more practical in like applying it to the sciences and really starting like producing it in a massive way?
No, but that's an interesting question, because every scientist that has seen this work always wants to quantify the impact. So they want to know, well, are you able to grow the exact nutrients to sustain a particular kind of body that needs certain kinds of minerals and not others? Well, how much waste are you actually diverting in this process? So there's a lot of interest from scientists in the project in trying to imagine if this could actually be something that could have some environmental impact. But the intention maybe on my end wasn't to commercialize it. It was just to kind of open our minds to alternative ways of being.
Yeah. I'm pretty sure in the future someone will wear it. It looks like something that a Ray Bradbury character would wear somewhere in Mars. So
actually, my sister yesterday or a couple of days ago sent me the Paris Fashion Week apparently had someone this past.
So this is again like the connection between art going to science and then science going to art. Yeah, it's really interesting. So going back to Dr. Israelian, I know that, and I think many people do know, that beyond being a scientist, you also are really passionate about music. You play the guitar and the piano and maybe some other instruments. And yeah, you've been also playing in bands and most exciting recent projects are with Brian May, about which we will talk a bit later. But yeah, I wanted to ask you about the project that you did with Brian Eno, which was the Star Sounds. So first of all, wanted to know how did you decide to collect a gallery or a library of Star Sounds? How did it all start? And then how did you turn it into a Star Sound project?
Yeah, it was a very interesting story. Sound waves, acoustic waves, which are pressure waves, right? They've been discovered in solar atmosphere in late 60s. So there was evidence that in the solar atmosphere there are sound waves, acoustic waves, very low frequency, but there are, right? Mm-hmm. And to detect those waves in stars, you need very precise instruments and techniques, and you also need models, very good models of stellar pulsations and convections and so on. The second order physics, what is happening in external layers of stars, right? So those things have been developed in early 2001, 2002. So those, and there was a new branch of astronomy emerging in early 21st century, which calls astroseismology. It was a seismology of stars. We know seismology of the Earth, which is studying sound waves, acoustic waves in the crust of the Earth. So with this diagnostics method, we can learn about earthquakes, we can learn about volcanoes and lots of things. So just studying sound waves in external layers in the crust and of the Earth. Apparently, we can do the same in stars. But the only difference that in stars we have gas. So the frequency of those waves is much lower. So we are talking about 1 or 2 minute frequency oscillations, but these are sound waves.
Yeah.
Nevertheless, we had no chance to detect those waves before we developed very high precision spectrographs and instrumentation detectors and so on. So once this was happening, I realized quickly that so this is very interesting, because soon we are going to start detection of sound waves in stars. Yeah. And I went to develop models of stellar pulsations and use observations of just a few 5, 6 stars, because it's very hard. It's not easy to detect those pulsations.
Mhm.
Do it with very bright stars, and you need big telescopes and so on. So I started to calibrate models, which we call it calibrate, so improve my models to make sure that the model works for 3, 4, 5 stars before I can apply to 500 stars or 10,000 stars. So I have to make sure that in my parameter space, my models are okay. They're doing, and so I started this work. It took me a couple of years, and then the models were fine, and I started to apply them for theoretical, for stars which are not yet observed. They will be observed in the future with different temperatures and composition and mass and so on.
Mhm.
I could apply them to calculate the sound wave spectrum in the atmospheres, because I know that my models are doing fine for 10 stars of different parameters, so they are calibrated, and I can go and apply them to the virtual to the library of stars which are not yet observed, just to investigate what we can hear.
Yeah.
But still, we had to speed up the the waveform, because the frequencies are still very low. They are 1 minute, 2 minute uh, frequency pulsations. So I have to move them to audio domain to hear those sounds without changing the waveform. The waveform is what will distinguish one instrument from another, right? So the difference between piano and guitar is basically the waveform.
Mhm.
So each star has its own waveform. So my job was to find those waveforms and bring them to audio domain and listen to these waveforms and to see what's the difference. So what happens if I change the mass? What happens if I change the radius of the star, or the composition? If I add more iron or less helium? So what is happening with the sound, right? So that was a fun. It was really fun. So I created this library, and I showed it to a couple of musicians, not just Brian Eno, but to a few others. And they were really, oh my God, really, this is so cool. So are these sounds real? I was saying, yes, these are real sounds, because those are acoustic sound waves. You know, in the past, there were many, not astronomers, but a lot of people were doing fun with converting radio waves into sound. But it has nothing to do with physics, really. It's just because radio waves are electromagnetic waves.
Mhm.
They are not sound waves. They don't come from the sense. A sound wave is a pressure wave. It forms in a gas. So so that was not real. But this is real. This is real, because these are real sound waves, and the spectrum of those waves, the waveform, really depends on physics. The shape of the mass of the star, the laws that govern the structure and the evolution of stars, and also the stellar rotation. So all those things affect the waveform.
Yeah.
So it was very interesting. And then at some point, I said, what happens if I combine the sound of all these stars? Like, imagine we have 100 million stars in a cluster. So I want to combine the sounds of all these stars and get the combined sound. So that was funny. So I started doing this funny experiments,
Mhm.
combining sounds of different types of stars.
Overlapping together.
Yeah, yeah. And then I also introduced the term which Brian Eno liked very much. He was referring to this everyone, citing me. It was called acoustic universe. So I was always saying we have an electromagnetic universe that we observe in
Yeah.
X-ray, in radio waves, in infrared. So this is electromagnetic universe. All right. Now we have also acoustic universe. Imagine if you close your eyes, you get a microphone, and you travel in the universe, and imagine your microphone can detect infrasounds and it can detect ultrasounds, but it's just detecting sound waves, pressure waves in a gas. So if you stick your mic into different stars in the stellar atmospheres, in galactic arms, in interstellar medium, you can find always in accretion disks, there's so many environments in space where you have these sound waves.
Mhm.
I was saying, what happens if you stick your microphone, if you travel with your mic in the universe, and just try to listen to these sound waves?
Yeah.
Can you identify which kind of object is?
Mhm.
You don't see it, but you hear it. You take a mic and you say, oh, this is a guy. Oh, this star has a mass of like that. This star has a temperature like this. just with the sound.
Gives them a characteristic.
Yeah, exactly. So it was fun, and I thought it was quite educative. So again, an educational project, and it makes it astronomy makes fun, and you can bring it to schools, to planetariums, and create a project. And I was on my way to do this, but I never had time to finish because the project is there, the sounds are there, and there are some compositions. But to take this to make a planetarium show or for IMAX or something would be really, really amazing. Yeah, yeah. So you will need to attract some sponsors and someone to
Yeah.
project
So
like.
the process. Yeah, we're looking forward to it. But in the meantime, actually, we have like a short excerpt of the sound of the sounds of the stars. So we're going to listen to it.
5 or 6 different stars. It's not just one star. It's a combination of 5 stars.
Yeah, overlapping on each other.
Yeah. I gave him that, so it was. Yeah, but it was fun.
So how did the star sounds come together? Like you pitched it to different people, and then Brian, was interested in the program and in the project, and that's how you published it.
Yeah, I mean, people like Brian, very, very high level musicians that super interested in science. In fact, once I asked Brian, I said, most of my friends are not scientists. Most of my friends come from arts and from business, from whatever, but they're not scientists. Maybe 10%, even less. And Brian told me, exactly the same with me. I don't mess around with musicians. I hate them. I said, so it's amazing. But these kind of people, they look for something different. They know lots of sciences. They prefer to talk to people who are not doing they're not composers or musicians. So that's why. And at a festival like STARMUS, where you bring all these guys, the big names, so often people ask me how you bring them together. It's so hard to bring music stars with science stars. So, and the question is very simple. If you just have a standard conference in astronomy or whatever, it's not interesting for people like Brian. It has to be super high level. It has to be at the Nobel Prize level. It has to be at the level of astronauts, of Chris Hadfield, and so on. Then these people will come. They will be only interested if you push the level of your science, and not only astronomy. It has to be everything. And that's what we have been doing with STARMUS. We never focused this on space. Of course, the core, the center is astronomy, but we always put around physics, chemistry, biology, everything is there. And it becomes really super interesting in 5 6 days. And we have a very light program. We never start at 8 in the morning, finish at 8 in the evening. So it's just after lunch, couple of hours, 3 4 hours, 20 minutes, TED format talks, very light. We give more time for networking, for cocktails, and for concerts, so people have time for interaction, to exchange ideas, and people love it. So that's when they come, they see that this is not a conference.
Yeah.
This is not a conference. It's just kind of a science, music, chill out area. You can network and communicate and meet friends, interesting discussions. So that's why STARMUS works. It works because right from the beginning we put a very light format for the festival, super light format. So don't get people, sleep at the conference, with a 45-minute lecture by a guy his very boring voice, and most scientists are not very good speakers. So you should find so this is the answer. So how we can be scientists and artists.
You answered part of my second question, which was about the STARMUS, because I think the Star Sounds kind of put the precedent for STARMUS. So you started it with Brian May, but before starting it, I've heard that, and you may correct me if I'm wrong, but your first encounter with him was when you were writing a screenplay or script, and you sent it to him. So I really wanted to know what was the script about? Was it a sci-fi film script?
Yeah.
And how then it become into the festival?
Yeah, it's I think it was 97, 98. I published an interesting paper about one of the brightest stars in the northern hemisphere, called Rigel. Rigel. It's a beta in Orion, beta Orion, right? It's a blue supergiant. So I was following this star for about 2 years. It's very interesting spectrum and changes, blah blah blah. At the end, I discovered that this star has huge prominences. You know, the solar prominences, right? The solar loops, the large magnetic loops. So I discovered that this star has a massive prominence. It has produced this prominence, which lasted about 6 months. And then there was a repetition, and then it has repeated about 2 years later, much smaller, but still it was a giant prominence. I was quite impressed because theory says that in massive stars you cannot have magnetic fields. So the question was then how you get this loop structure, how you get the prominence if there are no magnetic fields. So the paper was really challenging models. I published it, and there was a lot of citations and going to conferences. And then I came up with this idea. I said, look, if we don't understand how the prominence physics, we don't understand really, even in the sun, we don't quite understand the physics of prominences. So I proposed, I said, look, imagine that in the sun, in the solar atmosphere, we get a giant loop, a giant prominence. So that's going to smash the earth and destroy the planet and everything, the whole civilization. So it's quite an interesting idea. And I wrote a treatment in 10 pages, which called The Loop. The name was The Loop. All about the solar prominence, giant, supergiant prominence that was coming from the sun to destroy the earth. And we had only a couple of months to react. So the story was what we are going to do. And my idea was that if we have a network of, if we combine, I actually did some estimates that if we combine all electric power that we have on the planet, and if in a short time we create a supermagnet, we can enhance magnetic field of the earth a factor of 1,000. So we can create an artificial shield around the earth and protect the planet from the solar wind, from the prominence, right? That was a simple estimate. But then the whole story was that, all right, even if you do it, you need to agree between all nations and countries to bring together their power. And it's like the film Don't Look Up, very much in this style. So
Yeah.
you need to agree. The politicians have to come and agree. The military, so they have to shut down all the anti-missile systems, everything. So all the military, they have to shut down everything and combine forces. And the story was that so that was a story, and then what is happening next, and so on. And the main hero was an astronomer, the guy who detected the flare, and was going to report it. Pretty much like Don't Look Up, really, in a way, in a very the same style, right? And no one would believe in him until they see the loop, and the loop is coming, and you have counted a couple of weeks to react. And so on. Very interesting story. So send this to Brian, and so he was so impressed, and just
Yeah.
called me up and saying, "Wow, this is amazing." So then we met, and
Yeah, I can see
story.
it. Yeah. Well, that was a really interesting story. And then it put the grounds for the STARMUS Festival, which for our audiences to know, it's going to be held this year in Armenia. It's going to be in September, going to be a week full of events, celebration of art, of science. So yeah, we're really looking forward to it. And I have another question to Aroussiak, because I know that all her work revolves around the idea of the hypernature. So I know that you already have some kind of vision of what that looks like. So I wanted to ask you, what's the blueprint of the hyper nature in your mind? What's the layout of it that you think we should strive forward to?
Yeah, I think it's the recognition, and this was the first project that you showed was kind of the seeds of developing this idea, which is that, you know, right now, if you look at the food chain, the human has placed itself on the top, and all the other kind of species and everything is literally considered below the human. And it's really this, to go back to these ideas of symbiosis, it's really to demolish or, you know, destabilize this kind of power dynamic of the human being on top of everything, and recognize the incredible agency of every living species, from, you know, down to the microbial life. You know, if you start studying these entities, your mind is blown by just the amazing ways in which they contribute to our world. Even kind of microbes in the soil, and you know what they do for our world. And it's recognizing that each kind of organism and entity has an agency, has a kind of power, and collaborating and co-evolving with them on the same kind of level would be probably the blueprint. And this manifests in different ways in different projects. I'm currently working on one where, and in all my work, I try to focus and be at the scale of the human, because it's really, in the end, my work is trying to redesign the human, in the sense that it's trying to kind of shift us from a more wasteful, a more problematic kind of stance that we've had with the rest of the biophysical world, and kind of switch our rituals, change our rituals. And so one project I'm working on currently tries to feed a whole ecosystem of mushrooms, of fungi, particularly shiitake, and I can explain why, if it's of interest, why shiitake, with human breath. So I've created this kind of vessel system, where the human inputs their breath, and the shiitake takes the volatile organic compounds and the moisture from the breath, filters it, dehumanizes it, and produces more water. And this is through a process called metabolic water production. This is common to species that live in the desert that don't have access to water. They burn sugar and produce water to sustain themselves. So there's kind of excess water that gets collected in a cistern that gets distributed to a kind of an ecosystem. And this is imagining, you know, what our life would be like where our access to water has diminished in some kind of future state. So all of these projects are, you know, trying to bring the human, make the human aware of the incredible agency of the biophysical world, and allow them to partake in a more collaborative kind of relationship with them, with the hope of redesigning and shifting the attitudes of the human at the end.
That's a really interesting project and a really interesting blueprint. I myself am like more interested in the past, but like talking to you now and to Mr. Israelian, I'm really interested in your future. So yeah, looking forward to the results of the project. And so, since we have only 10 minutes before we start the Q&A session, I wanted to ask a last question to both of you about Armenia, because as you know, once upon a time we had a really prominent and flourishing Bioengineered observatory, and now it's very interesting that every year we're receiving a lot of submissions to Creative Armenia for projects, and so many films, so many stories or installations are about this place, this mystical, mysterious Aroussiak Observatory. And yeah, what's your idea of bringing together like the scientific and the creative aspect, and how can we make Armenia into like bring a new wave of scientific and creative collaborations, and create a new like a Caltech for Armenia that's really flourishing? How would you do according to your own fields and practices?
I sounds like Garik is Dr. Israelian is already doing so with the festival. That's an amazing kind of seed, I think. Sorry, I go ahead.
Well, I think nowadays you don't really just 21st century. We have so much data, and all this data is available. You don't really need to invest in telescopes and in telescope power and so on. You just need to have a brilliant knowledge of what is happening, what you can do, and if you have an amazing, very good educational system, if your university gives top quality students, I don't see any issues with doing Caltech like centers and then so on, because all this data which comes from James Webb and everything, just a few months later, it's all public. So you don't have to come up with a very fresh data and publish first paper. In fact, the first discoveries are always very, very rough and very, very first hand. So real science comes later. And you can have all this data in your computer. Everything is online. If you manage software, if you know models, if you know everything, you can do brilliant, brilliant, brilliant science without investing single US dollars in infrastructure and everything. You just need one laptop. You can do it. It's absolutely possible. You don't need to go to conferences and, well, it's nice. I mean, of course, you may have to meet people, blah, blah, blah. But forget, these days, with all softwares that we have, you can develop your own software. And if you have a knowledge, if you know, you can do brilliant science. It's not like 20, 30 years ago. So people are, no, we need observatory, we need telescopes, blah, blah. No, it's everything is there. And Armenia is a small country. We cannot put billions of dollars into telescope, James Webb. Even joining projects like this costs a lot of money. But I don't think that. If we invest 10% of that money into education and the quality of students, that is sufficient. That's more than sufficient. They can do their PhDs, they can do everything. We don't need infrastructures, expensive, very expensive. I'm talking about astronomy. Maybe it's different in biochemistry. Maybe it's different in biophysics. Then you need labs and so on. But at least in astronomy, we can perfectly manage.
Yeah, it's like mostly investing in the new generation of the rising scientists and creators.
Absolutely.
Absolutely. Aroussiak, what do you think?
Well, I think there's incredible assets in the sense that, or Armenia has incredible assets in the sense that it does produce a lot of great thinkers and a lot of great artists. So the idea is, if you have something already, how do you make it more fruitful? And perhaps it's kind of cross-pollinating earlier on, instead of segregating our subjects that we're taught in school, bring other kinds of perspectives into a topic, around a topic. And that might expose scientists to the arts, artists to the scientists, and this kind of fertile ground for cross-pollination might be might do what we hope that these kind of untraditional disruptive kind of areas of inquiry that certainly Dr. Israelian is part of, but many others too. It's really once you start to destabilize the frame that you've been taught to look at the world through, once you start to kind of look at other perspective on the same topic that you're studying, there's a lot of incredible things to learn about the world when you put your frame down and try to look at it differently.
It's like a symbiosis of different fields.
Yes, exactly.
Okay, thank you very much. So we are going to take a couple of questions from our audience. And in the meantime, if you still have some questions, feel free to drop them and we will get to them too. So the first question is from Irene. Was saying that today many people believe that the key to development of Armenian society and state lies in the technology or business thinking. and that art is secondary. What is your stance on this? What do you think should be done to bring more attention to the importance of art?
Yeah. Go ahead.
It's similar to the conversation we were having about the power of science fiction. I think art is something that makes you kind of look at the same things that we look at as humans, but through a really vastly creative and different lens. And it also is imaginative in the sense that it can showcase an alternative to what we exist in terms of the world. And in that, there is a power in pushing science forward. Scientists who have been trained a particular way and tend to look at kind of projects in a very closed for a reason. There's kind of a method that most scientists are taught to execute. And I think once they look at the same data through a different lens, it opens up a lot of new kinds of areas. And we heard from Dr. Israelian on the power that it's had on him and his, scientific inquiries. So I think to lower art, to devalue it underneath technology and business would be doing a vast disservice to the overall development of science, technology, and what have you. There's so many different examples of movies even influencing the development of technology. For instance, if you look at Minority Report and the fact that we didn't have any of those screens before, and it was really the movie that was the trigger for this development in technology. And so I think it has a lot of power that could be used to further advance technology and science.
Yeah.
I think the great advantage of art is, arts, you don't need much support from the government in arts. I mean, if I'm a sci-fi writer, I don't care for any support. I will just write my books. It's so simple. And if I'm a musician, take my guitar and create songs and sing them in pubs. If I'm good, if I'm popular, I will rise. So that's I think arts is arts. I have a very simple example. In Armenia, rock music and bands where I would say the profile of bands in Armenia were really low until 2012 and 13, 14 maybe. But the last 10 years, it was going up. Amazing. Now in Armenia, you have excellent bands, excellent musicians, at least in his, and also in jazz and many, for obvious reasons. No one has supported this. No one has done nothing. But you talk to musicians in Armenia, you talk to artists, they can all assure you that there was a kind of a revolution for any reason. No one knows why.
Yeah.
But we have amazing bands. I can count 10, 15, 20, really good. But we didn't have them 10, 15 years ago. So why? It's I don't know. Arts is very specific. It depends on very unknown factors. Somehow it will go like this. And the same with painters and with, of course, technology-driven art is different. And I totally agree. Then science and technology-related art is totally different. But we're talking about classical art, writers and so on. I don't think that you need the government coming and supporting you on. In fact, probably just the opposite. I think there's always better art when they have more oppression and more. So the artists sometimes they need this. They have to feel the pressure. If you are not pressured, if you are not under pressure, you don't create.
Yeah.
That's been always like this.
Yeah, I completely agree. At Creative Armenia, as Aroussiak also knows, we also think that artists not necessarily primarily need money or the grant to produce their work. They mostly need the advice, the mentorship, the strategic support to just bring their work to life. And yeah, that's something that we very strongly believe in, and that we are also pushing forward through our programs. So I hope, Iran, that answers your question. And in the meantime, we'll go to our next question, which is from Kanad, saying, talking about imagination preceding the reality, what would be the technology that hasn't yet been invented, but that you would like to see break through this during your lifetime? That's a really interesting question.
Go Kanad first. Aroussiak first.
Sure. I think, I don't know that we haven't seen it yet, but it is starting to be more, at least in my world, more prevalent is a shift in thinking about biology as a form of technology. So you're kind of engineering bacteria to do certain things. So it's starting now, kind of biosynthetics and this kind of treating biology as a form of technology. I can foresee this kind of, continuing and developing and expanding into the future. What that means, for the world, I don't yet know. It could, it could be quite dystopian if you follow one kind of thread with this, or it could be kind of remarkable. But there is incredible power in shifting our attitude and re-looking at a system that's not necessarily technology as we define it, more kind of on a mass kind of level, but kind of shifting and re-looking at biology as this kind of technological system that's able to work in the same ways as our kind of harder machines that we've had in kind of the previous decade and centuries.
Yeah, I think in astronomy is probably space tourism is going to yes. So I think very, very soon we will see the first tourists in the space station, and then going to the moon, and then going to Mars. So this is going to completely change a mentality. At least all astronauts, they claim that after returning to the Earth from the space, they change completely. I remember one of my guest astronauts was Baturin Yuri, said that astronauts has three personality: one before going to space, second during his flight, and the third returning to the Earth. So you are actually three different persons. So that's going to happen with most humans who will have a chance to fly to the moon or to go to space. But I'm also convinced that next Artemis project to the moon will quite change our mentality. Because imagine we are going to have high definition live cameras on the surface of the moon. So you turn on your laptop and the live see top quality what is happening on the surface of the moon. You will have different webcams in different directions. So that's amazing. You can imagine that you are going to feel the presence of space in your bedroom, in your house. You are going to see live some astronauts doing something on the surface of the moon and the others in space. And then later will be on the same on Mars.
Yeah.
So those things are really going to change our mind and mindset completely. Will be a different race.
I think space tourism especially can also be very commercially viable. So hopefully we'll encounter it very soon. So yeah, we hope that Kanad, both Aroussiak's and Dr. Israelian's suggestions will be possible in your lifetime too. So moving forward with our next question, which is Diana Aroyan. My question is about simplifying science for the public. Many scientists think it is an unhealthy trend because lots of nuance is lost. Many think it is essential to make scientific knowledge more accessible. What is your stance? I think, whoever wants to go ahead.
In collaborations I've done with scientists where we've tried to go after grants together, I think one of the elements that they value most in a collaboration with the arts is its ability to communicate or bring to the general public ideas that they wouldn't necessarily be exposed to otherwise, in ways that are engaging, in ways that are different. So it's not necessarily, to me, a dilution or a simplification of ideas, but rather a different way of presenting the idea, and a different creating opportunities for interesting ways of interacting with really kind of incredible ideas. So, you know, and Dr. Israelian talked about the kind of acoustic worlds of the stars, and that is a really a great example of not necessarily diluting this really complex idea, but making it engaging and making it immersive. And I think these are key to getting more people interested in the sciences and to engage in sciences in meaningful ways.
Yeah.
Yeah. I think in 60s, most scientists were like very ignorant about science communication. They were really considering this is, I don't have time for this, and so on. Carl Sagan was the one to make this revolution. He was the first to come and say, hey, so this is a different thing, and this is a different business. This is very serious. And he created, it was really a revolution. Cosmos has changed the world. So after Sagan, the whole sci-fi and everything started after Carl Sagan. So all the National Geographic and Discovery channels, he pushed everything. And I think it's a duty, all scientists, if you are a scientist, you have a duty, you have to do something to bring science to society. Doesn't mean you have to do lectures, because most scientists are not good lecturers.
Mhm.
There are many, many different ways to do this. I mean, you can write popular articles. You can join panel discussions, you can go to you can collaborate with artists, but just do fraction of your time, 5%, 1%, do something to bring the science that you are doing, your science, actually your research, explain somehow, create something. Because I think if you don't do that, if we all say no, this is not our business, just forgive it, it will be horrible. So that will be what happens. The film Don't Look Up is a very good example. So this is what will happen with our society if we ignore science communication. So
Mhm.
tomorrow you will have an asteroid hanging over there, and they will say, no, that's not an asteroid.
It's a good reminder to always look up.
In the future,
Yeah.
and the media will not be interested, and the politicians will ignore always, like they did always. So it's our duty. Scientists have to take care of that. They have to involve society. If they don't do that, no one is going to do this.
Mhm.
And artists are their their I don't know, the brotherhood and their friends. They are the ones to help science.
Yeah.
They will always give a hand. They will always collaborate with scientists. I was always saying we should collaborate with artists, bring
Mhm.
involve them, and they will be happy. They are super happy. They are very open, very very open. It's so easy to work with artists, but just do it.
Yeah. They also are interested in each other's work, and it's good that you mentioned Carl Sagan, because I think like Contact is a really great novel that you wrote, and it's also available as a really nice, well-made movie. So Diana, if you're interested, you can check that out. And yeah, it's also a good way of getting a glimpse into the scientific part of the world. So I think there is another small question from Iran to Garik. Dear Garik, what are your favorite cosmic sounding musical works? I would love to give them a listen.
Oh, cosmic sounding waves. All right. Yeah, I'm a big fan of Jean-Michel Jarre, for instance. Yeah, his first one, Brian Eno's music for the airports, and uh, mm, who else? Tangerine Dream, and there are so many. I would say. um,
That would be a good start for her to listen.
Start
Yeah.
Jean-Michel Jarre. Yeah. Yeah. Hmm.
Sounds good. And we have just a nice comment from Garik Israelian, who says that she's really excited about this session and sends greetings to all of us. So I think, yeah, that's a good point to wrap up our conversation. Thank you so much. This has been really insightful, very inspiring, I think, for everyone, for me too. Yeah, thank you, Aroussiak. Thank you, Dr. Israelian, for this really nice conversation. And to our audiences, I want to remind that tomorrow is our last day of Creative Armenia Week Summit. And it's going to be, this one is going to be a bit different because it is a live stream of our Artbox Creative Incubators celebration. We have finally wrapped up our program. We have 29 creative projects graduating from the Creative Incubator and moving forward with their creative projects, getting funding, investments, and shifting and moving forward the creative economy in Armenia. So stay tuned, join at 4 p.m. Yerevan time, and you will be able to see 29 great projects and get acquainted with them. So yeah, that's it for today. Thank you very much. Sending you all best and warm wishes to the island, to Los Angeles, to Aroussiak, Dr. Israelian. Yeah, and yeah, thank you very much. Have a nice day.
Thank you very much. Thank you, Aroussiak.
Thank you.
Amazing work. Congratulations.